bye. I feel better now.
Okay, guys. This is I'm going to go over the study guide for ecology. Your test, A-Day classes, is going to be on Thursday, and B-Day classes, the test will be on Friday. So let's just go over the study guide and make sure you have all the right answers. First of all, number 1, an organism that makes its own food, if you'll remember, is called an autotroph or a producer. Okay, so it says an organism that makes its own food is a producer. Another name for a producer is an autotroph. Number 2, an organism that can't make its own food is called a heterotroph. Another name for a heterotroph is a consumer. Okay, number 3, it says to distinguish between photosynthesis and chemosynthesis. Remember, photosynthesis is where organisms use the sun to make their own food. Things like plants, some bacteria, and some protists go through the process of photosynthesis. And chemosynthesis is where they use chemicals like sulfur to make their own food. And these are very rare organisms, but it would be like the archaebacteria and things that live down there in the hydrothermal vents. They go through chemosynthesis. Number 4, what do the processes of photosynthesis and chemosynthesis have in common? Well, they're both processes where organisms can make their own food. Okay, number 5, a single sequence of feeding relationships can be shown in a food chain. Number 6, each step in a food chain is called a trophic level. When I say primary consumer, secondary consumer, tertiary consumer, quaternary consumer, producer, I'm asking for the trophic level. Number 7, what are 4 types of consumers? Remember, you have herbivores, carnivores, omnivores, and detritivores. Number 8, a consumer that eats only meat is called a carnivore. 2 examples of carnivores are lions and tigers. A consumer that eats only plants, it would be an herbivore. 2 examples of herbivores are horses and cows. A consumer that eats both plants and animals is called an omnivore. 2 examples of omnivores. 2 examples of omnivores are, let me go back up, are humans and bears. A consumer that eats dead things is called a detritivore. 2 examples of detritivores are scavengers and decomposers. Okay? So number 9 says to distinguish between a scavenger and a decomposer. Remember that a scavenger actually eats things after they're dead. They kind of eats the leftovers. An example of a scavenger would be like a buzzard or a vulture or even an ant. A decomposer actually breaks down the dead things and puts the nutrients back in the soil, and that would be like a mushroom. Okay, number 10, how is a food web different than a food chain? There's actually a mistake there. That should say, how is a food web different than a food chain? Actually, a food chain is just a single series of feeding relationships. Okay, a food web is where you actually have a bunch of connected food chains together. Okay, let's look at number 11. It says create a food chain, label each trophic level, the producer, the primary consumer, secondary consumer, and tertiary consumer. So let's look right here, and I'll create a food chain. And this is the one I've used very commonly. Let's say that I have grass, grasshopper, sorry about the messy writing, frog, snake, okay, remember that the grass would be the producer, the grasshopper would be the primary consumer, the frog would be the secondary consumer, and the snake would be the tertiary consumer. Now let's say that I added another trophic level. Let's just say that a hawk ate the snake. That would be what we call a quaternary consumer. Quaternary consumer. Quad means 4. Okay, so let's look at number 12. What are the 3 types of pyramid models? Well, we had 3 types of pyramids. If you look on here, we had an energy pyramid. We had a pyramid of biomass. And we had a pyramid of numbers. I'm going to open that for you and show each one of those. Remember that an energy pyramid it just shows you how much energy is lost at each trophic level. A pyramid of numbers actually shows you how numbers in the populations decrease at each trophic level. And then a pyramid of biomass, that just says that if I added the masses of all things that live in that trophic level, it would decrease as you go up. So let me show you those. Okay, so this right here would be a energy pyramid, and it's showing you how much energy is lost at each trophic level. Remember that only 10% of energy is transferred from one trophic level to the next. So if we had 50,000 joules of energy here, then here we would only have 5,000. Remember, here we would only have 500, and on here we would only have 50. Okay, so that is an energy pyramid. And then we had a pyramid, a biomass pyramid, that shows you that the available biomass decreases at each level. Okay, and then we had a pyramid of numbers, and it shows you how the numbers in the population go down as you go up. Remember, you're going to have more producers than you are primary consumers. You're going to have more primary consumers than you are secondary consumers. You're going to have more secondary consumers than you are tertiary consumers. It has to be that way for the whole circle of life to work out. Okay, so number 13, how much energy is lost at each trophic level? Well, we said 90% is lost, only 10% is transferred. Number 14, how much energy is available at the 3rd trophic level? If the 1st trophic level has 300,000 kilocalories of available energy. Okay, so let me show you here. So I think we said that if we had, this would be the 1st trophic level, we said we had 300,000 here. Well, then here we would have okay, 30,000, and then here we would have 3,000, and then here we would have 300. So 1, 2, 3. The 3rd trophic level, the answer would be 3,000 joules. Okay, 3,000 joules. Okay, number 15 says what happens to the numbers of individuals in each trophic level as you go up? They decrease. Number 16, what does a biomass pyramid measure? It measures the total dry mass of organisms at each level. So that is all about food pyramids and energy pyramids. Basically, that's all about energy transfer. We didn't talk a lot about cycles, but let's go over that. Number 17, the continuous movement of water and its natural changes from one form to another is called the water cycle or the hydrological cycle. Number 18, distinguish between evaporation, transpiration, condensation, and precipitation. Basically, evaporation is the change of liquid to a gas. Transpiration is the loss of water through the leaves of a plant. Condensation is a gas back to a liquid. And precipitation, you know what precipitation is. It's when water returns to the earth through rain, sleet, snow, or hail. Okay, number 9, in the carbon cycle, consumers release carbon dioxide into the air through respiration. Producers absorb carbon dioxide and release oxygen. Carbon dioxide is also released by the burning of fossil fuels. Okay, number 20. In the oxygen cycle, Producers release oxygen into the air through photosynthesis. Consumers breathe in oxygen during respiration and release carbon dioxide as a byproduct. Okay, 21 involves the nitrogen cycle. Remember the nitrogen cycle? Nitrogen makes up 78% of the air, and it's actually in a form that we can't use. So bacteria and the roots of plants, especially the plants of, like the roots of beans, convert it into a usable form. That's called nitrogen fixation. Remember, lightning does that for us too. And denitrification is when it's actually put back into its original form, and that's done by bacteria too. As long as you know what's going on in the nitrogen cycle, you'll be fine. And then 22, explain what happens during the phosphorus cycle. Well, the phosphorus cycle is the only one that doesn't involve going into the air. Basically, consumers get phosphorus from producers when they eat them, and then phosphorus is put back into the soil when those consumers die and decompose. Okay. Topic 3, succession. Okay, the natural replacement over time of one community of organisms by another is called succession. 24, the gradual development of a new community from nothing is called primary succession. 25, where does primary succession occur? That's when you get land for the first time ever. 26, give 2 examples of things that can lead to primary succession. I would say like when a volcano forms an island, or when a flood comes and it even washes away the soil. Okay, so keep in mind that for primary succession that you also have to replace the soil or make soil. And remember that soil comes from the wearing away of rocks and things like that. Okay, 27, secondary succession occurs when a disturbance changes or partially destroys an ecosystem but leaves the soil. 28, what types of events would lead to secondary succession? Talked about how if I, stopped cutting my grass and left it forever, it would turn back into a forest. We talked about how if a farmer abandoned his farmland, that would lead to secondary succession. A forest burns down, loggers, cut down all the trees in a forest and it has to grow back. That would all be secondary succession. Okay, so if you look here, secondary succession, abandoning farmland, leaving a logged forest to regrow, or burning down a forest. Okay, let's go to number 29. The first species to move into a devastated area is going to be called a pioneer species. Those things are very small, such as lichens or mosses. They have to be real small because there's not a lot of soil. Okay, number 30. The relatively stable community that forms after succession slows is called a climax community. Give 2 examples. That would be like a forest that has regrown after a disaster, or even like a tundra or a grassland that has to reestablish itself. So if you look here, this was succession. Okay, just to recap a little bit, this was primary succession, where even the soil has to form. Okay. And then we have secondary succession, where it has to regrow after some kind of event and the soil is already formed. This point right here would be called your climax community, and the first species to appear are called pioneer species. Okay? And that is the end of video part 1. Now, look up Mrs. Floyd's Ecology Study Guide Part 2, and we'll finish going over the study guide.